Grade 7, week number 14, chapter number 14, a trip through geologic time. Lesson number 2, the relative age of rocks. Textbook page number 528 to 533. Welcome, dear students. I am your physical science teacher, Mr. Dimish. In this lesson, we are going to learn how geologists determine the relative age of rocks, and also how unconformities and folding can alter the order of rock layers. The position of rock layers. According to the law of superposition in horizontal sedimentary rock layers, the oldest layer is at the bottom. Each higher layer is younger than the layers below it. How old are rock layers? Geologists have two ways to express the age of a rock: the relative age and absolute age. The relative age of a rock is its age compared to the ages of other rocks. If you say that you are older than your brother but younger than your sister, you are describing your relative age. The relative age of a rock does not provide its absolute age. The absolute age of a rock is the number of years that have passed since the rock formed. It may be impossible to know a rock's absolute age exactly, so geologists often use both absolute and relative ages. Have a look at the rock layers. Geologists use the law of superposition to determine the relative ages of sedimentary rock layers. According to the law of superposition, in undisturbed horizontal sedimentary rock layers, the oldest layer is at the bottom. Each layer is younger than the layers below it. The deeper you go, the older the rocks are. Determining relative age. To determine relative age, geologists also study extrusions and intrusions of igneous rock, faults, and gaps in the geologic record. To determine the relative age, geologists also study extrusions and intrusions of igneous rock, faults, and index fossils. Molten materials beneath Earth's surface is called magma. Magma that reaches the surface is called lava. Lava that hardens on the surface and forms igneous rock is called an extrusion. An extrusion is always younger than the rocks below it. Magma may push into both bodies of rock below the surface. The magma cools and hardens into a mass of igneous rock called an intrusion. An intrusion is always younger than the rock layers around and beneath it. A fault is a break in Earth's crust. Forces inside Earth causes movement of the rock on opposite sides of a fault. A fault is always younger than the rock it cuts through. To determine the relative age of a fault, geologists find the relative age of the youngest layer cut by the fault. Using fossils to date rocks. To date rock layers, geologists first find the relative age of a layer of rock at one location. Then they can match layers in other locations to that layer. Certain fossils called index fossils help geologists match rock layers. To be useful as an index fossil, a fossil must be widely distributed and represent an organism that existed for a geologically short period of time. You can use index fossils to match rock layers. Look at the figure, which shows rock layers from 4 different locations. Notice that 2 of the fossils are found in only one of these rock layers. These are the index fossils. Determining relative age. An unconformity occurs where erosion wears away layers of sedimentary rock. Other rock layers then form on top. Gaps in the geologic record and folding can change the position in which rock layers appear. When rock layers erode away, an older rock surface may be exposed. Then deposition begins again, building new rock layers. The surface where new rock layers meet a much older rock surface beneath them is called an unconformity. An unconformity is a gap in the geologic record. It shows where the rock layers have been lost due to erosion.